Hello and welcome to non-IITian. So this is a problem on algebra from NBHM 2024. Okay. If you're enjoying the content, don't forget to like, share and subscribe to non-IITian. Let's quickly see the problem statement. So we are given two functions. Let f and g be functions from R except the point 0 and 1 to R except the point 0 and 1 by f of x equals to 1 over x and g of x equal to x minus 1 over x. Then what is the order of the group under composition generated by f and g? So we are to find the order of the group generated by f and g under composition. Okay, fine. So let's try it out. Okay, so let us first analyze f of x. So f of x is given to be 1 over x. Then what is f of x? So this is f of 1 over x, which is 1 over x, which is just x. Okay, so therefore f squared is identity, and the identity function is the identity function on the group under composition of functions. This is something we know, right? So this was actually very short observation. We are actually trying to do something. We'll see why I'm trying to find these out. Now let us analyze what happens for g. So I have g of x equals to, so what was my g of x? X minus 1 over x. Okay, let me change this color a bit. Okay, so we have g of x equal to x. Okay, I again forgot it. X minus 1 over x, right? So it is x minus 1 over x. Then what is g of x? So this is g of x minus 1 over x, which is nothing but x minus 1 over x minus 1 by x minus 1 over x, right? So this is x minus 1 minus x upon x minus 1, which is minus 1 over x minus 1. Okay, so then what is g of x? So it is g of minus 1 over x minus 1, which is minus 1 over x minus 1 minus 1 upon minus 1 over x minus 1. So what does this come out to be? So this is minus 1 minus x plus 1 over x minus 1 upon, this is minus 1 upon x minus 1. So this just comes out to be, so 1 and 1 cancels here. So this is minus x upon x minus 1 into minus x minus 1, right? So this is just x, right? Okay, fine. So therefore we conclude that, so let me just write it here. Hence we conclude that f squared is identity and g cubed is identity. So this is what we conclude yet of now. Now, what is fg? Okay, what is f times g? Okay, something which we can also conclude further from here is that f is equal to f inverse, as the inverse is in the group, and g inverse is equal to g squared as in the group. Okay, fine. Okay, now what is gf? Okay, gf of x typically. So we are under composition, right? So this is g of f of x. Do I have pages here? Okay, I have 2 pages here. Let me do it in the next page. Okay, fine. So we have concluded yet of now that f squared is equal to identity and g cubed is equal to identity. Fine. Okay, now what is g composed with f? So this is g composed with f because we are working under composition. So this is g of 1 over x, right? It was g of 1 over x, right? So this is what was the definition of g? X minus 1 upon x. So this is 1 minus x minus 1 upon 1 minus x. So this is 1 minus x by x upon 1 by x. So this is just 1 minus x. Okay. Now what is f g squared of x? That is f of g squared of x. Now what was g squared? We found out minus 1 upon x minus 1. So this is f of minus 1 upon x minus 1, which is f of 1 by 1 minus x, which is 1 by 1 by 1 minus x, which is 1 minus x. So therefore what we conclude, now observe that from here g squared is nothing but g inverse. So we conclude that my gf is equal to fg squared, which is nothing but fg inverse, isn't it? Now we are done. Why? Observe the following. We need to find the group generated by f and g, and we just found out that the generators of the group satisfy the following relations. I have g cube equals to identity, I have f squared equals to identity, and I have gf is equal to fg inverse. And now just recall, so this is the group we are concerned about, and recall the following group which is generated by r and s, such that r cubed is equal to 1, s squared is equal to 1, and rs equal to sr inverse. And this is nothing but the group D3, the dihedral group of 3 elements, right? And observe that these are actually isomorphic because they satisfy the same generators and relations, right? You can just take a map which sends f to s and g to r, and you are done, right? These are two groups satisfying the same generators and relations. So therefore the group we are concerned about, so let me write it here. So therefore the group which is generated by f and g, and we just found out they satisfy the following conditions, and gf is equal to fg inverse. This is nothing but isomorphic to the group D3, the dihedral group on 3 elements, right? So therefore the order of g must exactly be equal to the order of 3, which is 6, and so you're done. So answer, the order is 6. Clear? Thank you for watching. Please like, share and subscribe to Non-IITian if you like such content. Meet you guys soon.